Well, hi, everybody. My name is Brendan Coyne. I work for Clear Creek Systems. I'm happy to present for Stormwater Awareness Week one more time. I think this might be my 7th or 8th year working with this great event. I think it's very unique, and thank you all for attending. They ask us to kind of stay away from a commercial pitch or anything like that, and give us about 5 minutes to talk about what we do. So I thought I would do that right away, and then we can focus on the presentation for the remainder of the hour. I may not go the full hour. I'm probably targeting about 45 to 50 minutes. So a little bit about Clear Creek Systems. We are been providing services since 1994. We have a variety of locations across the Western U.S. I do understand that we're reaching audiences even beyond the West, California specifically, but we do have offices throughout the USA. We grew up from the West Coast and have expanded out quite a bit there. So Clear Creek Systems is a project-based company, not product. So we don't try to sell any particular products. We target solutions for individual problems that construction companies or industrial facilities have with their water. Includes stormwater and also other types of water that facilities might have, or remediation projects, etc. We use a combination of industry technologies to provide a complete system, not just a single product, but a complete system. We rent systems out. We sell permanent systems, design, installation, and provide the operations and support needed to keep those systems running and comply with any of the permits that might be applicable. Folks on this might be most concerned with construction general permit or the industrial general permit for stormwater. And we provide system operators that operate in accordance with attachment F of the general permit, for example. Again, temporary rental or permanent systems, flow rates from 5 GPM all the way up to 4,000, even beyond that these days. We treat for water quality, removing a wide variety of contaminants, suspended solids, turbidity, pH, hydrocarbons, metals, organics, nitrates, and some of the more exotic contaminants these days, including PFAS. And they're all within our wheelhouse. We hallmark ourselves on cost-effective solutions. It has to work for your customer or yourself, if you are the customer, to have any benefit. And finally, we always want to operate in a safe, as safe as we can. So safe operations is a key hallmark for us. Again, just some of the types of operations we get involved with. And I also, like to show these photos that show what systems, bigger systems in this case, look like. And today's presentation, we were going to highlight the techniques and equipment that are used in our industry to safely, efficiently, and professionally collect and treat stormwater. All this while meeting the needs of our regulatory authorities. So that would be the State Water Board or the local facility that takes your stormwater. We also want to meet our client needs. So they all have needs, right? They want to be efficient. They don't want to spend a lot of money. They don't want to have a lot of resources devoted to this. So it has to meet the client needs. And client needs might be things such as space. How much space do they have on their facility for something like this? We need to work as a team, all of us, to meet those needs. And finally, the workers' needs. So you have people out there on the job site, and they are oftentimes in environments when it rains where it's muddy and mucky and there's water everywhere. We want to make sure that they are given the best chance to do their job safely. All right. Nobody needs to be slipping in the mud while they are trying to put a scaffold together. All right. So this presentation will focus on capturing and treating stormwater with an emphasis on both passive and active treatment systems. We'll discuss some strategies and best practices, and oftentimes those best practices will tend to minimize costs. All right, so I talked about putting scaffolding together on a rainy day. Sometimes it's better to start with something that doesn't look right than try to explain something that does look right. So I have a few photos that I want to show here that we came upon this facility that's construction going on. We have stormwater that is collected here in the main alley. You have trucks and equipment traipsing out the water into the street. The street's getting muddy. It's getting carried down the block. It's not easy to work in this environment if you're a worker, and definitely not a good way to treat your stormwater. This particular one, that I would say half measures are not always going to be effective. Okay, so you see here we put down, our customer had put down some rocks and some trench plate to, little effect in the end. We still have that chocolate milk covered water on this site, heavy equipment pulling through there. Doesn't look like a lot of planning had been put into what's going to happen with this water. It's puddling right where it shouldn't puddle. Those two particular sites are kind of like, you could tell, kind of maybe more of an urban suburban environment. It doesn't always happen just there. It happens out in, the empty fields where they're putting in housing developments. In this case, maybe not a lot of thought has been put onto where the water is going to end up on a construction site, on this construction site. A little bit easier to deal with in this instance, but in the end, and a little bit of planning would have had our water end up in some kind of collection basin. This particular one, this job was shut down because they could not work in their environment. And this photo was taken, that was a few days later, and things had started to dry up. But it was only dry enough for us to start getting in there and getting a plan together with our customer and helping them to put their best foot forward for the next rainfall event. So just another photo of what actual systems can look like when they're out on a site. Not very pleasant to the eye. Might be considered dangerous. So just a little forethought on the layout of these systems and housekeeping can increase the job safety and ultimately save on costs. Again, nobody wants to see their sites looking like this, and you should not expect that from your vendor or your workers, whoever's doing your temporary treatment systems. It shouldn't look like that. So thinking ahead, we reduce all kinds of issues, and when we reduce these issues, we directly save on costs, and by saving on costs, we save on manpower. We save on the need for additional equipment. We save on the need for additional treatment. It all kind of comes back to the bottom line. So a little bit of money spent on proper setup and equipment is going to pay back dividends throughout the life of your project. So for the project planning, beginning of the project, we kind of want to take all of our data points we have available and come up with a plan. And these might seem pretty basic, and this presentation overall is kind of a 10,000-foot view on what these systems look like and how to plan for stormwater treatment. But all of them, no matter how basic your project might be, you're going to want to look at your stormwater pollution prevention plan, take into account the project duration. And if you're sitting on these events, your projects are going to be going on during this rainy weather seasons. We'll take a look at our where we're going to be at in terms of the existing and finished elevations of your project. Take that into account. We take into account if you're building something, we definitely don't want to set up some tanks and equipment where you're going to be needing to get to that area of your site. We'll take a close look at your permits. What permit are we working under? Is it the construction general permit? Is it the industrial general permit? Is there some other permit in place? We'll take a look at the receiving waters. So once your stormwater comes in and it looks like chocolate milk or orange juice, where's that water going to go eventually? Is it going to go to the wastewater treatment plant? Is it going to go to the storm drain, which leads to the estuary, or the river, or the lake? All these need to be taken into account. And then finally, contaminants. Are there any contaminants of concern? Is there issues with pH being outside of the neutral zone? Is there issues with that turbidity? I talk about the orange juice flavored looking water, or the Coca-Cola water or coffee water. Is your stormwater starting to look like that? We got to take a look at that. VOCs, metals, this term PFAS is kicking in. We're starting to see that. So, we're taking all of our data points and we are moving on from there to a plant setup. So a plant setup in this case is going to allow water to settle out. It's going to lend itself to a professional appearance. It's going to help us to meet our discharge requirements. And again, here comes that cost savings, etc. In this case, we in the photos, we're collecting water into settling tanks. We'll go over that in a bit. Or it could be as simple as a settling pond, where we have a conveyance of stormwater or groundwater collecting into a conveyance that leads to a settling pond. And they might not always call them settling ponds, but they often look like those types of ponds. In this case, we have water conveyed to I want a couple different examples of what that looks like. It could be a lined basin, as in the top right, or an unlined basin, as might show in the bottom left there. So we need to, with the proper planning and funds, you can make your site look like the top right, but you may not always have that ability to do something like that. So this particular one, I showed a slide of this earlier where they had to shut down the job site, and a proper site layout might look something like this, where when it rains, water is going to flow off to the bottom left of the circle, or the construction site, I should say. It's going to be pumped up to the perimeter header and piping, which you could see the white PVC at the top left, go all the way around the construction site and end up to a small little treatment system on the top right. Why does the water get piped all the way around? So equipment can come in and out of that driveway. There's no underground trenches or anything done that's going to get in the way. So with the forethought here, they were able to eliminate future issues with needing to remove lines and that sort of thing. So just an example of how that looks like. and an overhead view of the small footprint that this particular system needed. So there's space for a frac tank behind the job trailer, and you could see the perimeter water collection system coming around there. So the bulk of this presentation, we're going to talk about the anatomy of what these systems look like for stormwater treatment. They not only apply to construction projects, but they also apply to industrial projects as well. Main difference, as far as I'm concerned, is existing infrastructure versus temporary infrastructure. So the processes between the two different types of projects are very similar. And we'll go through this one by one, and when we're done, you're going to have a good idea of what a passive treatment system might look like. And I will dovetail at the end into active treatment and what that looks like and what we're able to accomplish with active treatment when compared to passive treatment systems. All right. So we talked about this job site here, and we'll start at the 9 o'clock position with the brown box that represents, where we're collecting our water. Okay. So in this case, we'd like to start work, and if we can, and then at a time when the sun's out and everything's not muddy and sloppy. In this case, we were able to put in a sump at the construction site here, represented by the little box at the 9 o'clock position here, and you see the low point there where water will collect because it's graded that way. We'll take advantage of natural water flow and a low traffic area. And when we talk about low traffic areas, that's on our sites. We don't want big forklifts traipsing through our water collection area. We don't want people walking through there, stirring up the muck and making water that would have been cleared dirty again. So we want to place these systems out of the collection areas out of the way as possible, so they don't interfere with the guys and ladies putting their systems together or putting their building together or whatever they happen to be making. So how do we get that water from that sump or pond to out of the site? Well, it starts with some kind of pumping system. All right, so there's two types of pumps often used here. One is called a submersible, and one's called a trash pump. And they pump water from the excavation to the settling tanks. Submersibles are exactly what they sound like. They go under the water. Everything goes in or is able to be submerged into your sump or pond, and they tend to want to just pump water right out of there until they reach a low level. They are solids handling. Solids handling means they're able to pick up pebbles and dirt clods and that sort of thing, and still operate. I mentioned they can be submerged. They can also be floated on a raft or other floats in the middle of a pond. They are almost always electrically powered. So you need a power source for them, and that electrical lead from that pump comes up out of the water and often leads to a generator of some sort. The trash pumps on the right are also solids handling, a little bit more bulletproof. They can be electrically powered or mechanically, which means electrically off of some kind of power generator, a generator. Or mechanically powered through the means of a diesel engine that is coupled to the pump. We select these pumps based on the site conditions. So if we have a really dirty site, it might lend itself to a trash pump. If we have a site that's 20 gallons per minute, we might select the submersible. If we have one that's 4,000 gallons per minute, we're going to be looking at the trash pumps. So we take all of our information that we've gathered so far, And that helps us to choose what kind of pump we want to start with. A couple of photos of submersible pumps being put into place. These aren't really good marketing pictures. I don't mean to say that they are, but I do like the idea of this life-saving apparatus there on the left, the ring. Safety has always got to be a priority. In this case, it was deemed necessary for this site where they put a ring out there. I've seen guys walk down in the mud into these pond areas to collect sample water. And I knew if they slipped on that mud, they were going to slide down the embankment and into the water and have no real way of getting up. So I just like to talk about safety as a priority whenever we're dealing with water. If somebody fell in that, got knocked unconscious, I don't know if anybody would see them in that type of water. So I just like to mention it for maybe it helps somebody do a stop work at some point if they ever need to bring that up as an issue. All right. So moving on from that, we pump our water often into some kind of settling tanks. It gives us time to aid in settling. It's our first stage to settle out our larger sediments. So those pumps will pick up sediments and dirt and deliver them to these tanks. And it could be a pond, a separate lined pond, often works as well. But oftentimes for temporary projects, anyway, we'll use these tanks. These tanks, I'm sure we've all seen them on the side of the road. They are 17 to 21,000 gallons capacity. Nominally, we call them 20,000 gallon frac tanks. Okay, that's the size and number of the tanks that we use are selected to allow stormwater to settle. So we like to use a rule of thumb for every 200 GPM. Well, let's say every 150 GPM, we like to have at least one of these tanks. So a 300 GPM system might have 40,000 gallons of settling in tanks. These tanks allow for surge capacity and consistent flow rates through the system. So those submersible pumps and the trash pumps I just talked to you, they might deliver flow rates that vary depending on the level of the collection area. It might be 10 GPM, it might be 100 GPM, or even more. But once they deliver water to these tanks, we can now process at a consistent rate. So that's what we call for surge capacity. It can take any flow rate and kind of reduce it to a single flow rate for treatment. Two things to remember here, if you're unfamiliar with these, is if you have a one acre site and you got an inch of rain, you're going to end up with about 27,000 gallons of water. If you're not able to discharge that, and you need to figure out if you hadn't done your planning, for example, you're going to need a couple of tanks, right, to be able to hold that water until you figure out what to do with it. So you can do the math there. If you had 2 inches of rain over your 2 acre site, it just starts adding up from there. So again, frac tanks range from 18,000 to 21,000 gallons. All right, so once we reach a certain level in those tanks, hopefully we've had all of our sediments settled to the bottom of the tanks, and the top side starts looking clear, the water starts looking clear on these tanks. From there, we can use a transfer pump to pump from the tanks through downstream filtration. A particular note in this case is I don't see any other pumps, so you won't need a whole bunch of more pumps. You just need the pump coming out from the submersible, the job site, and the pumps coming out of the settling tanks. All right, so again, these transfer pumps are very similar to what I showed earlier. Often we do not use a submersible pump in this instance. We'll use a trash pump, again, electrically, mechanically powered, solids handling, capable of various flow rates. They're sized for the system. Oftentimes, a side note, our system sizes are governed by the permit and the acres of your site. And often, when we talk about general permits, we need to be able to handle a flow rate that can treat a 10-year, 24-hour storm event within 72 hours. All right, so ultimately that's how we get to our flow rates. And the water that we have coming out of those tanks, if we're lucky, it's clear, but often whether it's clear or not, we're going to run through some kind of filtration system. I'm going to talk about, pretty much a workhorse of filtration. In this case, it's called a sand filter, and it usually comes on a skid, and it polishes the water to prepare the waste stream for the waste stream and discharge, or it prepares for any advanced filtration that might be needed. So it's a mechanical filter. They're filled with gravel and sand, and what's great about them is that they are able to clean themselves periodically. So you don't have, it's not like a bag filter where if you put a filter sock inside of a canister, that sock is going to fill up, and you're going to have a guy out there, or lady, technician, I should say, out there changing bag filters in the middle of a storm event on Thanksgiving, on the weekends, at night. You don't always need that with a passive treatment system and use of a sand filter. It's meant to automatically clean itself, backflush itself, back to, and when it backflushes, it's a dirty, it's your dirtiest water, and we usually backflush that into a frac tank, weir tank, or it can go back into your collection pond. All right. It's a mechanical filter, like I mentioned. Under normal operation, it will remove particles down to about 35 microns. And using a flocculant, you can get down your NTUs quite a bit, less than 10, and that would meet the requirements of an active treatment. So without a flocculant, we're still dealing with passive treatment and a simpler operation. So picture here the orange juice colored rain water on the left, and with the proper treatment, it will always look like the water on the right with the clear jar after filtration. Okay, so keeping it moving here, there might be a need for specialty media filters after we've taken out all the solids. So that clear glass of water, stormwater, it might have some molecular contamination. It might have metals. It might have VOCs. It might have any number of contaminants of concern. So from there, we'll move down to our specialty media filters. And this might be a good time to point out we're basically treating here from the biggest things in our water, our biggest particles, to the smallest particles. So starting with rocks and sand and grit and silts, all the way down to the molecular level in that order. So these filtration vessels come in various sizes. These ones are in the photo might be a 4-foot diameter by 7.5 foot tall. Each one of these might handle about 100 gallons per minute. These media filters get pretty large, 20,000. They might hold, I'll say, 720 cubic feet of media, so we're talking about 8 to 10 foot diameter vessels for very large high flow systems. They're selected again based on what we need to treat and the flow rate at which we might need to treat on site. So they each contain media, a little photo of a cross section of types of media that are most often used. And again, they're used to remove things like metals, VOCs, or other contamination. I don't mean to say that one media will remove every type of metal that might be in your stormwater, but again, with that proper planning, taking the data from the work we put in at the beginning of this project, we're going to know what some of that lab analysis might say and be able to select a media and do bench testing, make sure it works when it gets out to the site. It's much more difficult to do after it's rained and your collection ponds are overflowing and you're under pressure to get rid of water. So a little bit of planning, all this can be laid out before the storm hits and ready to go when it's time to mobilize. So once we get our clear water that is free of contaminants, we can filter that water out and discharge to our body of water that we're going to. We're in California, where I am. That it can go to often go to state waters if there's no other problems. All right. So I'm gonna now switch over to our what we call active treatment. Sometimes that orange juice glass of water, it looks like orange juice or muddy. Sometimes we can do all that and the water still comes out looking like coffee. And that's can happen for a variety of reasons. I'd like to put this little chart in my presentations to kind of demonstrate how that can be. We've all played with jars with rocks and gravel and stratification that happens when you shake up the jar. Well, we know if we had a storm water with a lot of gravel, that gravel is going to fall out into the bottom of that tank or that pond really quickly, right? It's not going to stay suspended. But the finer and finer the particles get, it takes longer and longer to settle out those particles. And some of them, you start getting into the silts and clays. They take longer and longer. You're not going to end up with clear water at the top of those treatment tanks. All right. So those colloidal particles can be demonstrated. They can stay in suspension for hundreds of years. All right. So obviously that's not gonna work. But you know, how do you know what you're dealing with? It's not that hard, right? You don't always need. And when you're in the field, you don't always need to go to the lab right away to know what you're dealing with when it comes to this type of thing. A little water bottle in the back of the truck. Go take a sample of your storm water or any water on the site, mix with your soils, and shake it up and put it on your workbench or your tailgate. Shake it up, and if it still looks like this, you're going to need some additional treatment. All right. Sometimes it looks what you do that, and it settles out really quickly, and you end up with what's shown on the right side of this picture. All right. Just takes a little time, and you can have pretty clear water. Right. Oftentimes, for construction sites anyway. You'll end up with what looks like in glass number 2 from the left. All right. Industrial sites might look like glass number 3. Okay. So what do we do when we're in a position where we need to treat more to a higher quality? we have to introduce active treatment systems. Um, they're often used to treat for turbidity and pH. They control and inject flocculant, and flocculant reduces turbidity. I will talk about flocculant in a little bit. We also can control and monitor for pH, and we can comply with our permit regulations. All right. So with the addition of flocculant, this is there's a few different types. I'm going to talk in generalities here. All right. So this kind of demonstrates what happens. So when you have very turbid water, which is that coffee water or the orange juice looking water, rusty water look, you have a lot of particles floating and suspended in your water. They won't settle out. They often all will have a charge, and in the West anyway, it's mostly a negative charge. So they're all like the negative end of a magnet, and they're all repelling each other. So the water never has a chance to settle out. When we introduce a flocculant, we kind of change the charge of the water and start to bind the particles together like a positive and negative of a magnet. They'll stick together. And when they start sticking together, the particles get bigger. And when the particles get bigger, they lose, and the charges change, they will fall out of solution. So in this case, we have added a flocculant and shook up the jar on the top left. We let the jar settle out, and in the bottom left, and we could start to see the particles starting to bind together. And as time goes on, moving to the right at the bottom, we see a mass start to form at the in the middle picture, and when left to settle out, we can get results that look like that third picture in the middle of the bottom there. And after we do that, we are able to filter that water and end up with, again, the clear jar of water, which is on the right-hand side. Okay. Where does this all happen? At this, if we're having that type of problem where we have a high turbidity, we don't use jars of water. We use those frac tanks that I showed earlier in the presentation. So that's where all that happens. The magic happens in there, and we continue through our process like I had shown earlier. Other things that will require active treatment are issues with pH. So if we are out of the neutral zone, 6.5 to 8.5 area, that can vary depending on your construction site. You may have 6 one day, you might have 6.5 the other day. So if we're in the area beyond neutral, we will often need to treat for pH as well as turbidity. It's usually by adding a chemical of some sort, we can bring pH back to neutral. But most often, we have our issues with turbidity. And this is just another demonstration of what that looks like and how that goes. In this case, it's like dark water, and we move to, at 30 minutes, pretty clear water. So that's how quick it can happen. No treatment, what it looks like at 30 seconds, at 60 seconds. So we don't need a lot of tanks to allow this water to settle out. Again, the number and size of tanks or ponds for settling is selected based on our total flow. So that kind of summarizes a basic anatomy of treatment. That module that I just spoke about, I have in the middle here, and we will add our flocculant in between, in this case, the submersible pump and the tanks, And one of the maintenance items on these is, especially as the stormwater system goes on and on, if we're lucky and we get rain, the tanks will start to fill up with sediments on the bottom. And when that happens, we start losing some of our storage capacity in those tanks. And it's not uncommon to have some kind of service, or not uncommon to have these tanks be serviced by a back truck or somebody that comes out and sucks out the dirt and everything that's at the bottom. And kind of comes back to the beginning, right? If we are traipsing through our job sites and have the water that we're going to be collecting constantly stirred up with dirt and sediments and oils and greases from leaking vehicles, these tanks are going to fill up faster. So again, if you look at the project as a whole, it all can work together to reduce overall costs and make for more effective treatment. So with proper planning and implementation, treated stormwater will often be of higher quality than background water levels. I want to play this video. I hope it plays here, but at the top right of the photo is background water quality. So water coming from the stream, and this clearer water in the front is the treated water coming out of a stormwater treatment system. And it's just a kind of a good demonstration of what it looks like. And when you have a regulator or your customer coming, asking what they're spending this money on for tanks and treatment, it's good to be able to demonstrate what you're able to accomplish. This was a Caltrans site up by Willits, and the water was treated at the top of that hill and flowed through a diffuser at the top all the way down into the creek here. And yeah, really good results with the stormwater treatment system that was put in place. So start to summarize here. A well thought out plan result in an economical setup, smooth installation, creates manpower savings. I don't know what you guys budget for a guy every day, but $1,000 a day savings for every man woman you don't have to have on dealing with this stuff. It ensures a efficient utilization of your equipment. You're not having equipment out there that's not needed. The planning eliminates that, and a professional appearance, which is very important to our customers, every single one of us. It's an example of what that might look like. This particular one, I believe, was in the 3,600 gallon per minute range. A lot of tanks there, right? Well, they could not put in a settling pond, and that was their only choice at this point to put in some tanks. But that's how big they can get. And I thank you very much for your attendance today. If I can help in any way, please let me know. I know I kind of this is a simplified presentation for a wide range of folks who might be interested. I can take just about any one of these slides and do an hour on it. We do lunch and learns, and I'm happy to help anybody with their projects for this winter. Please feel free to call me if I can be of any service whatsoever. There's time left. I think if there's any questions, I'd be happy to take them.
Perfect. Well, thank you, Brendan. And it looks like we do have one question. Where do you usually dispose of flocculant and sediments?
Yeah. So the flocculant itself, we do have to test for residual flocculant whenever we use that, to make sure that it's not still in stormwater when it goes off to the state waters or wherever we're putting it. So with respect to the sediments and everything that might collect in that tank, we'll work with some of the disposal companies that that may select their disposal facility based on what is in what we know to be in the sediments inside the tanks. Those tanks might collect sediments that are impacted by pollution. They may be high in metals. They may have PFAS in them still. So I can't give any one facility that they're taken to. We need to make sure that we do a proper lab analysis on that. Sometimes they're left at the facility because they're just native soils there. But every site is going to be a little bit different.
Perfect. Well, that about wraps it up for today. I don't see any more questions coming through, but if you missed any portion of this workshop, it was recorded and will be up on our website, which is stormwaterawareness.org. And it'll be up there for you guys to watch in about 24 hours. And you can also watch any of our other previous workshops that you may have missed or register for the workshops that are remaining for this week. So thank you, Brendan, and thank you everyone for joining us. And we're hoping you're enjoying Stormwater Awareness Week.
All right, thanks again.